Hi, in this video, I just want to introduce you a little bit to routing principles. So every router maintains a table known as a forwarding table or the routing table. And it tells the router how to forward packets. And that's really the job of the router. Router connects multiple networks and forwards packets from one network to another network. Okay, so the main columns of the forwarding or routing table is the destination. Where is the IP packet going to? And this is typically a network address, either IPv4 or IPv6. Also, where do I send this next? What is the next hop router and or exit interface? Now, usually it should include the next hop address. I won't go into the details here, but in most cases, the next hop address is really what we want to see. The exit interface will most likely also be included, but I won't go into the details here. All right, and the whole idea here is as the packet gets forwarded from one router to the next, it's getting closer to its final destination, right? We want it to get closer and closer along each router hop as it gets forwarded from router to router to router. Okay, so the forwarding table is, again, we mentioned the destination address, which is usually a network address, and the result is sending it to a next hop address. Now you see direct there. Direct might mean that the destination is on one of its directly connected networks. It doesn't have to forward it to a next hop router. Okay, and we've seen in previous video, when we looked at the Cisco iOS IPv4 routing table, got a little look at that, so you know what these IPv4 routing tables look like. At least you've been introduced, familiarized with it a little bit. Okay, so some key routing principles, and I like these three. They're actually from Alex Zinnan, that has done a lot of work with protocols and part of the IETF, Internet Engineering Task Force. He also wrote a book years ago that I read, and one of my favorite books I've ever read, Cisco IP Routing, that kind of looked at the internals of how these routing processes work within Cisco. But what we want to look at here is his three routing principles. So the first principle is principle one. Every router makes its decision alone based on the information it has in its own routing table. So this is key because router R1 here, it has its routing table. Okay, it's going to make decisions based on its routing table. It has no idea what's in router R2 or R3's routing table. So when troubleshooting routing, what you have to assume is, I have to realize is just because R1 knows about it, knows maybe about the destination network 192.168.2.0, that it's in its routing table, doesn't mean that R2 knows about it or R3 knows about it. Okay, R1 is only concerned about itself and is making decisions solely based on the information it has in its routing table. Okay, principle two. Again, the fact that one router has certain information in its routing table does not mean the other routers have the same information. And I talked about that a little bit already. Okay, just because router R1 knows about it doesn't mean router R2 knows about it. Okay, so R1's going to, like we said in the first principle, is going to make its decisions based on what it has in its routing table. And it will be up to R2 to make decisions based on what it has in its routing table. Now, can you imagine if we had bad information here? If R1 says, I get to 192.168.2.0 through R2, what if R2 had information that said, well, I get to that network through R1? Well, actually what we'd have here is something known as a routing loop. This is not good. Okay, and this is usually due to either misconfiguration or in dynamic routing, we have some kind, could have a misconfiguration issue with in our dynamic routing, but could also have some problem with something called convergence that hasn't happened yet. So anyway, it's important that the routers have something, let me mention a term called convergence. Convergence is when routers all have complete and accurate knowledge of the routing topology, so these routing loops don't happen. All right, let's get to the third principle. Third principle states, just because a router knows how to because routing information about a path from one network to another does not provide routing information about the reverse or return path. It's always easier when I read sometimes, right? Okay, what that means is, let's take a look here. Actually, let's take a look at R3. Just because R3 knows how to get to this destination network for packets going back to PC1 doesn't mean that R3 knows how to get there. Or let's take a look at R2. Just because R2 knew how to forward packets to 192.168.2.0 to R3 doesn't mean that when R2 receives a packet for the return back to PC1 that it knows how to get there. Routers have to know about all networks if it wants to have end-to-end connectivity from one to the other. Okay? Again, we get back to the convergence, complete and accurate knowledge of the network information in the routing domain. Okay, so I hope this helps you understand a little bit about routing and when we get into static routing and dynamic routing and other videos, these routing principles play an important part. Okay, always kind of keep these in the back of your mind because this is a key to understanding how the routing protocols work, how to statically configure routes, and how to troubleshoot. Okay, all right. All right, so hope that helped and look forward to talking to you in other videos.